going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over Syslog, or the system logging, as it relates to iOS. So this is another one of those lectures that's going to go into our IP services, and another way that we can monitor things happening on our individual devices or on our network. So with that being said, let's go ahead and jump right into it. So, an agenda for today. So first, of course, we're going to start with our Syslog overview. What is Syslog, and then why do we need it? What is the purpose of it? Why is it something that we need to learn not only as network administrators, but also for the CCNA exam? And then we're going to get into the Syslog operation. So how does Syslog work on our actual iOS devices? And how do we use it so it can benefit us as a service on our network? And then we're going to go over just some verification. And you notice in my agenda here, I don't have a configuration section because typically Syslog logging is enabled by, it's not enabled by default, but you do configure it, but it's not like you're configuring ERJRP where you're putting in an autonomous system number and network statements. You're just turning the logging on. That feature's already on the iOS. And then you can also send these syslogs out to servers. So that's going to be part of our configuration. And there is a lab, but really we're just doing a lot of verification with the syslog. So with that being said, let's go ahead and get started. So syslog overview. So it stands for the System Logging Protocol, and it's a way for network devices and also servers to send standardized messages to a logging server, or on iOS, the logging buffer or console that is local to the iOS. So again, on Cisco devices, we have syslog messages that will pop up on our CLI when we're logged in that give us alerts of something that's happening on that actual device that is local to that device. And then these syslog messages all have different categories, or what we call severity levels. So there's going to be 8 severity levels in syslog. And these different severity levels are going to tell you different extremes. So the lowest severity level, or I guess numerically the highest, like level 7, is just kind of telling you, hey, this is happening, but it's not critical, right? It's not an emergency. And then level 0 is like, hey, this system is hard down, it's unreachable, we are not going to be able to communicate, we need to check this error out now. So essentially all syslog is just logging error messages that have different severities according to its own custom syslog severity levels. And then of course we use UDP port 514 when we're actually sending syslog messages out to a logging server. So that's important for anybody that sits at the edge of the network, right? If you're a firewall administrator or you're configuring ACLs at your core router or that demarcation point, and you and your syslog server sits off-prem somewhere, you're gonna wanna have that port kind of memorized for your firewalls if you're sending syslog messages remote to a remote server. So why we need syslog? So syslog messaging, it's important to alert network administrators of changes on the device. And we can accomplish that with syslog. It's going to help us troubleshoot. It's going to help us perform some root cause analysis on the device, because when we look at that log and we see maybe a CPU message threshold error, or that an interface went down, like a tunnel interface, we can kind of get to the bottom of it and we can quickly figure that out with the syslog messages. So syslog servers can also be configured to send notifications, and you can kind of set rules up in that syslog server saying, hey, if we get a level 0, I need you to email me, send me an SMS, and make my car alarm go off because we're hard down and my company's losing money now, or the company we work for is losing money. So syslog is a very important tool we can use, and we can either further manipulate that, because with the syslog messages, it's going to be a long text string. And for some of our advanced viewers in there, you know that there's something called event, I'm blanking on it, but event management scripts. Or EEM scripts for short. And what those scripts do, they do a lot. They allow you to kind of automate some processes locally on your Cisco device or your iOS. And in enterprises I've worked in before, we've set up EEM scripts that get triggered based on a syslog notification. So essentially, it's a script saying if this syslog message comes up, then execute this CLI command. And that's not the verbatim syntax of the EEM script, but that's kind of the logic of it, right? If this syslog message appears, we need you to do something. And you can kind of automate that on iOS with the EEM script. It's similar to what you do in cron jobs in Linux, but in Cisco, we can use syslog and EEM, applets, or scripts. Okay, then let's get into the operation of syslog. So the syslog protocol is going to start by sending messages and debug output to a local logging process internal on the device. So what do we mean by that? So by default, if we turn syslog on, and let's say we, to this device, not to our server there. If we turn syslog on, it's going to just be sending those log messages to an internal buffer, or that internal local logging process that's going to be internal to the iOS that we as network administrators could only see if we were either remoted in or with physically through a console, or let's say we were remoted in via SSH. Then we'd be able to see that syslog archive or that logging buffer. Now, how the logging process manages these messages, the stores that's available, what messages are actually going to be stored in the log is based on device configuration. So essentially, if we don't want levels 4 through 7 getting stored into our device, which is kind of common because these are just kind of simple things that are happening on your device that don't necessarily make it go down or warrant an emergency. Maybe we just want levels 0 through 3 to be stored in our logging buffer because that's the important ones that are going to bring us hard down or affect communication on our systems. So again, they can be set to that internal buffer, and that's only going to be viewable through the CLI of the device. And again, the CLI is either when you're SSH'd in or when you're consoled in. And let's go over the syslog message formats. This is going to be very important. So now we're going to get into the levels of syslog on Cisco. And I'm not going to say it's important that you memorize every single level and what it does and what it means in the description. What is important is that you understand there's 8 levels and that 0 is the worst thing that can happen, right? That is an emergency, meaning that system is unusable. So essentially, if you have a level 7, that's just some debugging information. Essentially meaning it's just information coming across our CLI that's just happening on our device. It's not breaking anything, right? It's just information that we wanted. And then that's why I said like levels 4 through 7, sometimes we don't even want to log those because it's just ridiculous, right? Sometimes we may want to log debug messages to go back and look at later if we're doing troubleshooting that is kind of unrelated to any emergency on the system. Like maybe we're just trying to figure out why some routes are still getting propagated even though we're trying to apply a distribute list. So we can do debugging. You know, there's so many different reasons why IPsec isn't coming up. We can run debugging. But these levels right here, 0 through 3, or really 0 through 2, are the ones that are like, okay, we need to get on that system now to fix something. Especially 0 and 1. So it's just important that you understand this. And then another thing that's important is you understand these definitions. So when you see log emergency, you should automatically think 0, log alert 1, 2, 3, 4, 5, and 6. And this is going to be important kind of for testing, right? So you understand that emergency is the worst and that alert, critical, and error come after that. Because I feel like with these, you can kind of decipher which one is worse, right? What's worse, a warning or a notice, just based off the English language. So you can kind of decipher those, but these kind of always mess up my students a little bit. Think which one's worse. And what also messes them up is when you're deciding what syslog messages you want to save to that logging buffer or send to a syslog server. When you set level 7 to be captured, you're actually setting level 7 and down. So you're going to capture everything. So that's something we're going to go over as well. So now let's go over the Syslog message format. So levels 4 through 0, again, are the ones that affect our systems the most. These are going to be error messages about software or hardware malfunctions. And that means the functionality of that actual individual device is going to be infected when you see anything from level 0 through 4. And then the notification level, or level 5, this is going to be just for normal events, stuff that's happening that maybe you, the administrator, have done, like an interface coming up and down, you shutting and no shutting, when the system restarts. And then 6, this is going to be just informational stuff, right? That's not affecting the device, but maybe you need to know. Like when a Cisco device is booting, it may let you know via Syslog on the CLI, like, hey, the license has been accepted. Awesome. And then, of course, the debugging level. This is output that's going to be generated when you, the administrator, come in and you say debug IP EIGRP packets. That's going to be level 7 Syslog messages. And they're going to come across the screen looking like this. So this is kind of a good example. If you see this Syslog message has a level 6, and you can tell because of this number right here. And we're going to break down the format of these messages further. So to kind of further break down the Syslog message format, so there's going to be these fields here. A sequence number, a timestamp if it's configured, and same with the sequence number. These are not by default turned on for Syslog. You'll have to actually enable these sequence numbers and timestamps, which you want to do because it gives you a sort of order of operations to things. This will give you like from 00 to 99, or just an example, right? It could be 0 through 1,000 sequence numbers. And then the timestamps are actually going to give you a date, so you can see when and what time something happened. And then we have the facility. So this is going to be what the message refers to. So if you go back, the facility on this one is license. It's talking about a license. And then the severity level is going to be that Syslog severity level that we talked about, which is again 0 through 7. So that's 8 levels. And then the mnemonic, I think I said that right. This is going to be a text string that describes the message, you know, what's going on. So here you can see the mnemonic is up, down, saying that an interface port channel changed to up. That's its state, it changed to up, okay? And then a description, this is going to be the rest of that text. And this is actually telling you, like, hey, this interface port channel 1 changed state to up. And now that you kind of see these Syslog messages, going back to those EEM applets I was talking about, if you want to configure some scripts, you could say if my Syslog message has a mnemonic of up, down, then execute this CLI configuration. So you kind of see how Syslog messages can really help us with a lot of the automation and troubleshooting, as well as just also giving us some monitoring tools to see what's going on in our system. All right, let's go over the service timestamp. So again, I was saying earlier that we have to configure if we want an actual date and time. So by default, log messages are not going to be timestamped. So they should be timestamped because we want to know when something's happening, especially if we're sending it off to a Syslog server, and if we're just doing the local console messages, right? Or the local Syslog messages are being stored in our buffer. So you can see here's what a timestamp looks like. Here's what a Syslog message looks like without the timestamp. You can see it just starts with that Syslog message. And then here's the configuration. So service timestamps, and then you have to tell it you want the date time with this log and then date time command. And then we'll get the date and time. And this is going to be going off your system clock too. So the important thing with like NTP we were learning about earlier in this section, synchronized timing is very important, especially for something like this. Because if you're trying to do root cause analysis and your clock is 3 days off, that's going to kind of mess up maybe a chain of custody if you're going over incident handling, right? So it kind of all ties together. And then by default, log messages are sent to the console. Some iOS versions buffer log messages by default too, but it's also something that you may have to configure. So here you see the buffer logging and then the console logging. So all different things we can configure. And then we can also configure to send our syslog messages from our iOS devices to a syslog server. So you see here just a quick example. We're using this application, TFTP D32. It's a TFTP server to actually send our syslog messages here. Or really just to send that syslog buffer or console. We can also send that as well as and the individual messages that you can see here, a level 5, and telling us that there is a configuration change made on the console. So now how do we actually configure that? So if you come here, the first thing we're going to do is type in logging, and then this is going to be the syslog server IP. Depending on your iOS, like in our lab, there's actually a command you may have to put here called host. It just depends on iOS. I think these images are from my old CCNA course I taught back in 2015 that was on older iOS devices. The syntax is essentially still the same. It's just important that we understand that we need this logging command first, and then we can use our context or command sensitive help to get us to where we need to be, right? Which is sending syslog messages out to a server. So that's going to be the logging host and then IP command, and this is going to be the IP of the syslog server. Okay, and then the logging trap message. So now we're going to decide what levels are we going to actually decide to send to our syslog server. So if I put logging trap 4, that's saying, hey, I want to send level 4 syslog messages and lower to the syslog server. So this command is saying levels 0 through 4 will be sent off to the syslog server. And then this is just a source interface. We can choose which one of our interfaces on our router is going to make that connection, which is going to be the source IP, making the connection to the syslog server. It's really just up to you, right? And this command has nothing to do with syslog. All we're doing here is shutting and no shutting that loopback to generate syslog messages on our CLI. And then we can see them populate over here in our syslog server. And that's exactly what we're going to do in our lab too, except I don't use TFTP. We're going to use something called Kiwi Log Server, free product delivered by SolarWinds. All right, and then verification. So verification on your syslog server is easy. You just look at your syslog server and make sure that it's working, right? But on the CLI, if you want to look at your console, your buffer, you can just type in show logging. And then of course we have our pipe command, which can use regex or regular expressions to kind of filter out what we want to look at, because those buffers of that log console can get pretty packed with messages. So maybe we kind of want to use that pipe command with regular expression to see, hey, we just want to see messages that said change state to up. Okay, or maybe we want to see things because we configured our timestamp starting on June the 12th, 2235, because that's maybe when we went hard down on our device. And now we drove to our data center and we're consoled in. All right, so I believe that's going to be it for this section. So in our next video, we're going to go over an actual syslog lab. And in that lab, I configured my Kiwi syslog server locally on my system. We have our EVE-NG topology that's going to be bridged out to my local network, and we're going to set up a syslog server. So I want you guys to stay tuned, and thank you for viewing.